find the volume of the larger whose base is bounded by x-axis, the parabola with square cross sections perpendicular to the x-axis. The x-axis and the parabola negative x squared plus 4. Alright, so it's going to be 2 and then over 4. So it's going to be something like this. The x-axis is going to be let's see, like that and this. You can see. So we're doing dx perpendicular to the x-axis. See, this is the x-axis, the perpendicular of that's perpendicular. So the cross sections keep going dx. They're going like that, no? So they're gonna be like that. So it's gonna be, when we do it, it's gonna be integral, and then you're gonna find that area here, dx, or is area, and then dx, and then the bounds from -2 to 2. For sure, -2 to 2, and then the area is, we could do the area as a square, so we can rewrite this as s squared, s squared, where s will be this, no? This is s sine squared, no? All right, so that's s, and s is just a function, no? Yeah? So we're going to go from -2 to 2. S is the function, which is 4 minus x squared dx. Put that in the calculator. Let's just kind of get this done with. All the algebra of it, whatever. But just let's setting it up is most important. Get your calculators, and what is that? What are you guys getting here? Would you get, Sean?
5, 12.
All right. Okay, you do all the 512, 15 if you. So let's move on. Volumes with cross sections, triangles, and semicircles. We were supposed to do last Friday. We were supposed to do squares and rectangles, and we just did squares or whatever. And then so now we could have done the whole just one time, the whole lesson. The definite integral from a to b of f of x dx finds the area under the curve. Okay, now it's going to become the base of a three-dimensional object with cross sections that are. Now we're going to do triangles and semicircles. So basically, again, it's going to be, if it's dx, if we go dx, the rectangles go dx that way, then it's this dx. But if we do if they do the dx dy, it'll be like that. But we're doing dx in this particular one, and the area is what you need to know what they are. So if it is a semicircle, what do you think it's going to be the area of a semicircle? What's the area of a circle? Pi r squared. And then what's half a circle? Semicircle divided by 2. So that's it. So it's going to be pi r squared divided by 2. That's what's going to go in there. See, that's what we're going to do. This one's going to go there. If it's an isosceles triangle, isosceles means that the sides are the same here. Say this is almost a equilateral triangle, but isosceles is that two sides are the same. And what would be the area of something like this? What would be the area of something like this? Well, you could see it right here. If you have an isosceles, which I drew, no, say isosceles, this is this. What would be the formula for an isosceles triangle? Look, it looks like a square. Let's just kind of does look like a square. Let's see. This is equal to this, and then flip it, and then this is equal to this, and it's like this. So it's half a square. So this will be s squared divided by 2. Yeah, just to remember these formulas, just kind of like find your own way of remembering isosceles triangles. So that s squared over 2 goes in here now. Equilateral triangle. It's a more involved one, and I'm not even gonna. We can come up with the formula for an area of an equilateral triangle, but here it is: square root of 3 over 4 times s squared. Square root of 3 over 4 times s squared, or just you have to memorize these area formulas for the different kinds, and they all, depending on what they ask you, that's what's going to go in here for this A, you know. All right, let's go. I'm going to move on from this, and you guys, you get it. So you go to doing the problems now. All right, let's go. We're gonna go number 1. You can go back to the website and get anything you're missing. All right, 1. Find the volume of an object with the base bounded by the x-axis, the y-axis, and y equals square root of 4 minus x, with semicircular cross sections. The cross sections have the diameter in the base and are perpendicular to the y-axis. Perpendicular to the y-axis. We got a problem. So they're going to be dy's. So there's the shape of it. Let me give you some time to actually copy this down, and so we can do it. So perpendicular to the y-axis. Something like that, perpendicular to that. So it's going to be dy. Area, no, volume. And it's going to go from what to what? 0 to 2. And then area here, no? Area. So we're going to use we want to do semicircular. So what was it for semicircular? What's semicircular? What was the formula for semicircular? Pi r squared divided by 2 is the area. Okay, let's put that in there. So volume is 0 to 2. Area is pi r squared over 2 dy. R, the cross. R has to be, because it's saying that the cross section have the diameter in the base, so it's gonna go like that. So let's see if we can go picture it. It says that this is the diameter, no? This is diameter, no? And what's the relationship between diameter and radius?
Radius is half of it.
Or okay, or you could say 2r is diameter. That also, no. But what is it that we are? Okay, we go with what you just said. You said half. Yes, we go with that. So diameter, and we're saying that radius is equal to half the diameter, no? Yeah. So we're gonna plug in for r 1/2 of d, no? I don't know. Let's just do it like that. Let's go. Let's just. So we're going to go volume is equal from 0 to 2. R is 1/2 diameter squared over 2, the quantity over 2 dy. Then we're going to do what? That's a lot. 0 to 2. It's going to be 1/4, 1/8 that we're going to factor out, and then factor out the pi. So look, let's factor it out, no? So we're going to 1/2 is 1/4 and 1/8 pi. Factor it out, and then we're going to have d squared, no? dy. Yeah, no? Making sense? Now what's d? Isn't d again just yeah, what is d? Everything's in terms of what? dy, no? dy. So we better have this in terms of y. So we have to solve here for x, no? So it's going to be what? If we go there, we're going to go, let's go, I'll go here. We're on a space. So we go y equals what? Square root of 4 minus x. Square it, both sides, y squared equals 4 minus x. Move this over this way. X is going to equal to 4 minus y squared. we'll just take that 4 minus y squared. Okay, so 4 minus y squared. So and then it's going from 0 to 2. 0 to 2. So you're gonna put this in the calculator. Hopefully it works out. No, it's gonna be what 1/8 pi 0 to 2, and I said what 4 minus what was it?
4 minus y.
Dy. Put that in the calculator, and I hope that gives you the the answer correct. What you guys get?
2 pi over
Let's see. Let's do the. Oh, it's not gonna be this number. It's supposed to be. It's supposed to be the same though. Yeah. It's not. What do you? But it's supposed to be the same. If this is true, let's see. Yeah, look, because this is gonna be 2 squares 1/4, no? It's 1/4, no? Because this 1/4, you take this 1/4 out, it'll be pi over 8. Is that what I had?
Yeah.
Pi over 8, and then I left this as 4 minus. Yeah. Oh, hold on. It's supposed to be squared here. 4 minus 1 squared. Hold on. Did I d squared? D is that? Why didn't anybody say anything about me not writing that d squared? I didn't write it down on here. It is squared. Let's see. Yeah. Hold on.
Yeah, I got it.
Yeah.
This is squared.
It was supposed to be squared here, something. But it's more about the reasoning through. It's got to be correct. Let's do one more, no? Let's see how. Find the volume of an object with the base bounded by the x-axis, x equal to 9, y equals square root of x, with isosceles, right triangle, cross sections. The cross sections are perpendicular to the x-axis, so we're doing dx. This is hold on. So what is the formula for isosceles? What was it?
S squared.
And we put it here, s squared over 2 s. So we go 0 to 9. S is what? So is it really that easy? What is it? One last one, I think. Well, I'll just do one last one here. Find the volume of the shape with the base bounded by the circle, and cross sections are equilaterals, perpendicular to the x-axis. So it's dx, but this is symmetric. We could have done just the same doing dy, but it's dx. Didn't we do this already?
Yeah, those are the squares.
What's the area of a equilateral triangle was square root of 3 over 4? S squared? S Is that really what it is? Is it that's the formula? S? S is S this is this what they call S?
Yeah.
Okay. Um and we do have what? That x squared plus y plus y squared equals 4. And we want it in terms of what? We want this is what? Dx, no? So we want it in terms of solve for what? It's solve for everything is solve for y because we want everything in terms of x. So move it over. Y equals going to be, let's just do the positive one. So y is equal to, move it over, 4 minus x squared. But that's just giving us what? It's just giving us this, no? Like from there to here, no? Like it's a positive one, y. So what do? We double it, no? So there's going to be 2 of it. So then 2y will be 2y. This is another y. 2y will be 2. So there it is, no? 2y would be s. S is 2y. S is 2y, and 2y is this. S is 2y. So the volume will equal from 0, negative 2 to 2, square root of 3 over 4. S is going to be 2 square root of 4 minus x squared, the quantity squared dx. Yep, put that in the calculator, that should work. What was that? What are you guys getting here for this? I don't know. I guess we could have just done that. We did it?
Yeah.
Yeah. That's kind of the idea. Oh, good. We're done.